Hello everyone. So today we're going to do an example. The first one is going to be a significance test, and then I'm just going to do a confidence interval with the same data. So this example is wine good for your heart. A researcher from University of California decided to collect data on the average per capita wine consumption and heart disease rate in a random sample of 19 countries for which data is available. And this table displays the data. And the question is there statistically significant evidence of a negative linear relationship between wine consumption and heart disease deaths in the population of countries? So we're looking to see if drinking wine reduced heart disease. And significance level is going to be 0.05. So the state part, your null hypothesis is going to be your true population slope is equal to 0. We're testing to see if there's a negative relationship. So our null hypothesis is that the slope is going to be 0. Now, for population, we use beta. So beta equal to 0. Our alternative hypothesis, we want to see if there's a negative relationship. So our slope should be less than 0. Now we got to make sure we define what beta is. So beta is the slope of the population regression line between wine consumption and heart disease rates. That's what we're looking at. And then our significance level is 0.05. So that's what you need for the state. Then the plan, you can do a couple things right away. You can do the independent condition and the random condition without doing other things on the calculator. So the independent condition we want to see is our sample size less than or equal to 1/10 of our population size. Also, we're going to do a t-test for slope. So 19 less than or equal to 1/10 of all countries. And then our random condition, we want to make sure it's a random sample. Now for the linear condition, we need to check our scatter plot to see if the data is linear or somewhat linear. For our normal condition, we need to check to see that the residuals show a somewhat normal curve. To do that, you can make a histogram, a dot plot. For today, we're going to make a histogram. So we don't want any strong skew or outliers for that normal condition. And then for equal standard deviation, we need to look at the residual plot and make sure that there's no type of pattern on that residual plot. We want random scatter. All right, so on your calculator to do that, first thing you need to do is make sure you have your data in list 1 and list 2. Then you can run linear regression on list 1 and list 2, and you can store the equation by hitting second, or not second, just regular vars, y variables, and you want to store it in y1. So that tells us our slope is negative, our correlation coefficient is 0.84, our slope is negative 22.97, and our y-intercept is about 260.56 from the data we have. Now, since I stored it, you can see in y1 there is the equation. Now we need to check the scatter plot. To do that, hit second plot. We want to plot between, so scatter plot is the first one, list 1, and list 2. If you hit graph, make sure you do zoom 9 to get the scatter plot. So there is the scatter plot relating wine consumption and heart disease rates. So the linear condition is met. Then we need to check the normal condition. To do that, you need to fill up a list with residuals. I already did that. But to do it, highlight list 3, hit second stat, and get to your residual list. Click enter, and it'll fill it all in for you. So what we need to do is check a histogram of those residuals. So first thing I'm going to do is turn off our equation, so that's not in there. And then go to stat plot again. This time we want a histogram, and we want it of the residuals. Our residual list is list 3. Graph, but then zoom 9. And there is our histogram of the residuals. As you can see, there's no strong skew or outliers with that. Last thing we need to do for our conditions is check the residual plot. Now that is a plot between a scatter plot between our original X list, which remember was list 1, and then instead of using our Y's, we're going to use our residuals. Graph, zoom 9. So there's our residual plot. There's no pattern in here, which is good. We're looking for no patterns, especially that Christmas tree where it starts off small and gets bigger as you go. So there's all our conditions. They have been met. Now the do part, we want a test statistic and a p-value. Go to stat, tests, linear regression t-test, using list 1 and list 2. And then we want our slope. We're predicting our alternative hypothesis that our slope is less than 0. Calculate. So there you can see our test statistic is negative 6.46, which tells us our slope that we got is 6.46 standard deviations below the mean. And our p-value is 2.9566 times 10 to the negative 6. We'll always look out for that thing at the back. E negative 6 means you move the decimal point 6 places. So our p-value is pretty much 0. And then if you scroll down, you can see it tells you all that other information we found before. Standard deviation of the residuals, slope, y-intercept, r-squared, and r. So getting back to our problem here. We used a t-test for slope. Our test statistic was negative 6.46, and our p-value was approximately 0. Then our conclusion is, assuming that the true slope is 0, so we assume the null hypothesis is true, we had an almost no probability, our p-value, of getting the slope we did from our sample. I think it was like negative 20 point something by chance. Since 0 is less than 0.05, we reject the null hypothesis. P-value is less than alpha level, we reject, and then we have convincing evidence that the slope is negative, basically. There is a negative linear relationship between wine consumption and heart disease rate. For a confidence interval, the state changes a little bit. We no longer need hypotheses. So our state is we just wish to estimate the true slope of the true regression line predicting heart disease using wine consumption. Then our plan is much the same, except now we're using the t-interval for slope, but our conditions stay the same. The do part, now if you just go to your calculator and just go to tests, now we're just doing a linear regression t-interval. Boom, 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 boom. Tells us our interval is from negative 30.47 to negative 15.46, which matches what our significance test told us. All values in here are negative, so we would reject the null hypothesis. So there's our interval, and then our conclusion. We are 95% confident that the interval from negative 30.47 to negative 15.46 will capture the true regression line, slope relating wine consumption, and heart disease rate. So we're 95% confident that it's going to be somewhere in there. I hope everything's going all right. Please ask questions if you have them. Remember, scheduled office hours are Monday, Wednesday, Friday from 1 to 1:20. But if you want to create a separate conference with me, we can do that. Just reach out to me by email, Google Hangout, whatever, and we can set up a time where I can help you.